This video is going to look at further properties and ways of representing vectors. First, the easier one to think about is how to represent vectors geometrically. And so here, geometrically, it's just really shown as a ray. And the way we indicate the ray, or the vector, is that we begin at the initial point. So again, here's our little journey that was shown in the previous video. And so we would begin here, so this is our start. Okay, I'm also going to call this the initial point. So initial, where you start, and then this is going to be the end, and this is also called the terminal point. Okay, and what the vector does is it extends from the starting to the ending point. We indicated that it's a ray with an arrow at the end, and then we also give it this label of a vector v, and then to indicate that it's a vector, we put an arrow on top. Okay, or a ray, I should say, a ray symbol on top of it. Okay. Conversely, if you label this as like point A and this point B, you could also call this, instead of vector v, you call that AB, and then the vector would point from A to B. So just be aware of that notation as well. Okay. So geometry, simple as making a vector here, or a vector by doing a ray from starting to ending point. Okay. Now also just be aware that you could also see this as a composition of two vectors. So you go from this point from A, and then we'll call this C, and then we call this AC vector, or we could just call this vector W, for instance, or something else. And then you could also do something like this here, and you could call this CB vector, or vector, let's see, UV, we'll call this vector U, okay? Something like that. Alright, so geometry, make a ray, extending from starting to ending. The other representation of vectors is algebraically, okay? And to do this, this is going to involve a little bit of notation, and the notation we're going to use is, instead of parentheses that we would use to communicate points, we are going to use angle brackets. And what this means, what this notation means, is that from the initial point, so we already are at the initial point, we move A units A units horizontally and B units vertically. Okay, so for example, if we look at the displacement vector, which is the vector here from the initial point to the terminal point, so this is start and end. So this point, what did we say it was at 7, 4? And this point is from, let's see, -6, comma -8. Okay, so then that means this vector, let's call it D for displacement. We're going to call it vector D is the same as, and I'm going to use angle brackets. Now, I want you to try and name this on your own first. Again, A is going to represent the total horizontal movement, and B is going to represent the total vertical movement. Okay? So try that on your own, and then resume the video. And here's the answer. So I got -13, -12, because again, from starting to ending, you start here and you move 13 units to the left, which we indicate with a negative, and then 12 units down, again, which we indicate with a negative. Okay, so that's the displacement vector, and then you're going to have some opportunity to find the other two vectors that I mentioned before coming up here. Okay, so now here, the next thing that we want to talk about with this is, remember when we were talking about vectors, we said a vector has magnitude and direction. And so the magnitude, is really just the length of the vector. But the magnitude, we represent it as this kind of double absolute value sign around it, called the norm. And it is simply just a squared plus b squared. So if we do that here, if we look at the magnitude of vector D, this is going to be the square root of -13 with parentheses squared, and then plus -12 with parentheses squared. Okay, and so then this is going to be that square root of 313 that we saw before. Okay, but anyway, why does this make sense? Well, I think if you think about it long enough, the length or the magnitude of the vector, since it is a straight line, it's just the length of that line, which is our distance formula, right? Okay, so now, this path that we were doing before, we said it was composed of two vectors, right? We called this kind of well, I think previously we called it like vector W and vector U. Okay, so we go from here to here, so right there, that's W, and then from here over to our ending point is vector U. And I'm curious, geometrically I'm going to just remove that because we did that on the previous slide, but algebraically, what is W? So it's going to look something like this, and what is U? Okay, so I want you to resume the video when you have an answer. Alright, and I actually made that into a quiz, so we will give you the answer now, and we find that vector W is going to be, okay, so this point is 2, -7, right? We move -5 for W, so we move left 5 and down by 11, okay, from 4 to -7. Okay. Another way of doing this is you can do, for the x-coordinate, you could do final minus initial, so 2 minus 7 for to get -5, and then for 11 you can do 7 minus -7 minus -4. -7 minus 4. Okay, and then similarly for U, you're going to get -1 in the y, and then -8. Okay, so those are the answers that I got. Check and confirm that those are what you got.